In this video I want to give a few examples of Kirchhoff's junction rule, which says that the total current entering a junction of a circuit must equal the total current leaving that junction, that same junction of the circuit. So let's apply that to this example right here. So I've got some sort of power supply. Here's the positive terminal, there's the negative terminal. So current's going to flow this way. Now there's a junction here, so it's going to split. Some current's going to go this way, some current's going to go this way. The current meets up again here, flows back to the power supply. So in this example, we have 8 amps passing through this resistor, which must then continue here. So we have 8 amps going into this junction. We must therefore have a total of 8 amps leaving the junction. We see 5 amps leaving here, so this here must be such that the total current leaving this junction is 8 amps. So I1 must be 3 amps. Now what about I2? Well, we've got 5 amps coming this way and going into this junction, 3 more amps going into that junction, so 8 amps going into this junction. So 8 amps must leave that junction, so I2 must be 8 amps. So just to summarize this whole big picture for this particular circuit, 8 amps of current leave this terminal, pass through this top resistor, come here, it splits into 5 amps going this way, 3 amps going this way. The 3 amps and the 5 amps come back together to give you a total of 8 amps here, which then flows back into the power supply. Just to make sure we have this, let's do 2 more short examples. In this example, I'm not going to show an entire circuit diagram, just a portion of a diagram with a junction. So at this junction, we've got 4 wires meeting right here. I see 2 amps flowing in here, 6 amps flowing in here, 3 amps flowing out. So far what I have is 2 amps and 6 amps in and 3 amps out. Well, if I've got 2 and 6, a total of 8 amps flowing in, I better have a total of 8 amps flowing out. Here I see only 3 amps flowing out, so this remainder has got to be 5 amps flowing out of the junction. Let's check. 8 amps flowing in, 8 amps flowing out, we're good. Alright, let's do one more. Alright, in this example, I see 6 amps entering the junction here, 4 amps entering the junction here, 10 amps leaving there, 5 amps leaving there. So let's total up what we have so far. We've got 6 amps and 4 amps entering, so a total of 10 amps entering, but a total of 15 amps leaving. So the entering and leaving currents are out of balance by 5 amps. So we need 5 more amps entering the junction right here to make it balance. Let's just double check. We've got 6 amps and 4 amps and 5 amps entering. That's a total of 15 amps entering the junction. We've got 10 amps and 5 amps leaving. That's a total of 15 amps leaving the junction. So 15 amps entering, 15 amps leaving. The junction rule is satisfied. All right, that's it. I hope that helps.